Hello, everyone. Welcome to the town hall today of September 19th. Talk about a lot of things this time around. We have a lot of presentations, so I won't be going too much into the various blog posts and forum posts and media that we have available over the past 2 weeks. Why don't we go ahead and get started because it's so packed. And today, we're lucky enough to have JB join us from People Ops to talk about some of the various shout outs happening, all the appreciation happening around the IFT. What's up, JB?
Well, thanks, Corey. Hey, everyone. JB here from the People Ops team. Hope everyone's doing well. I'm going to flash up, I think, 9 or 10 shout outs that we got for people. Just some really nice appreciation for some of the great work that's going on. We've got some individual appreciation and some team stuff. So I'll flash it up. I'm not going to read word for word. I'll let everyone do that. But there's some really, really lovely stuff for people to have a look at this month. So without further ado, first up is the notorious Jacob from the Infra team, doing a great job helping out the team. I'll give everyone a few seconds to read about why Jacob is awesome. And thank you, Sid, for the shout out. I'll have to have a drum roll. Drum roll for the next shout out, which is for Rahul on the Status Network. Just being super positive and supportive all the time and great communicator. So thank you, Rahul, and thanks, Philip, for the shout out. And next up, there we go. Great. Next up, we have Lucas and Felicia from the Status team. Just great work bringing translations back to the app and the website. That's a general shout out from the whole org because a few people sent that in. So well done and thank you to you guys. And then next we have Kachow in Waku, and shout out from Frank. Frank's really good at shout outs. Thank you. And so this one just for all the work you see on the screen in front of you. Thank you, Kachow. And next we have Gabe in the VAC team. Shout out from Richard. Thank you, Richard, for shipping Universal Connectivity app and all the other stuff. And like the little quote at the end, dude's a machine. Maybe that should be a tattoo or something on your profile. Next shout out is for Jerry. Long shout out. Thank you, Rick, giving great detail on why Jerry is so fantastic. Don't think anyone will be surprised if anyone's worked with Jerry. Great work, Jerry, and thank you, Rick. And next up, a general shout out. So quite a few people dropped a note just to say how great it was to see the Circles progress, to see how everything's going with Circles. I know there's quite a few people behind this. So if you're involved in Circles, thank you. And just know that quite a few people in the org have said, well done and great work. A good job. And then a big shout out from everyone to the Nimbus team for the new release this week. Again, this got quite a few people, a couple of the council members just giving a bit of shout out for a great effort. So well done, Nimbus team. And I think this might be the last one, the tokenomics team. Again, quite a few people dropped some feedback in here. We just noted how great the team were to work with, what great impact they're having, and how nice it is to work with them, which no one ever says about me. So great to hear the tokenomics team is doing a great job.
Anyone would ever say anything good about you.
And that was it. So I think 8 or 9 really great shout outs. Thank you for everyone. I think it's really important we just take a couple of minutes to recognize some of the hard work that's going on. We'll do another one of these in a month if we can get time on the town hall. So if you have anything in the meantime, drop it in the People Ops channel to tell the person directly, or let me know and we'll do it this way next month. Thank you, everyone, and thank you, Corey.
Thanks, JB. Appreciate it. All right. Always good to get some recognition on the good work happening, and unfortunately, there's just so much more going on. So, see some good work. Tell JB so they get appreciated, because that is only a fraction of the good work that I see around here. Next, because is in such a late time zone, we're gonna have them on, talk about some of the cool stuff happening on the comms team. Jinho and Jules, bringing you on. Jules, here you go. Got that. I'm gonna back out and let y'all take it away.
Oh yeah, sorry guys. Hey everyone, I'm Jules from the comms team, web developer, and I'm with Jinho. And today we wanted to present you the work we've done to support the growth of the Logos open source community. And so this is a portal we've built. We called it Logos Contribute Portal. So yeah, let's go. So what is this portal? For us, it's two things. A way to acknowledge publicly our contributors and show, give the visibility to the work and their contributions. And the second thing is a way to lower the barrier of entry and to onboard new open source contributors. So on the screen, you can see just two screenshots of the app, what it looks like. So we've got on the left a contributor directory, which is simply a list of all the contributors that have helped us in the last 12 months. And then for each one of them, you can see a few details of their contributions, a list of what they contributed to, and yeah, there are total contributions as you can see on the screen. So now, why do we think that this contribute portal is important, and why do we need it? So in our opinion, it's essentially just for one thing, and this is ecosystem growth. And to have ecosystem growth, we think that we need recognition and ease of access. So why recognition? Simply because recognition will bring retention by showcasing our contributors' work publicly. It will show that we care about what they do, and also it will show that they are not alone to contribute, and that it will create a community bound around our projects. And then ease of access, well, it's quite straightforward. It's just because by lowering the barriers of entry to newcomers, we just bring more people and we raise the chances of them contributing their first PR or any contribution they can make. So yeah, and those two things together will, we think, bring ecosystem growth, because highlighting what our contributors are making and making it easier for new people to come in will just, we think, reinforce the Logos reputation in the open source ecosystem, and also create a sort of social proof around Logos that will motivate people that are already helping us to grow inside the community, and also attract newcomers, attract new open source contributors. So how do we manage those contributions? How do we want to manage them? Well, this is quite straightforward. We have two things, proposals and issues. So proposals, as you can see on the left, is just a form that you can use if you already have an ID, if you already have built something and you just want to share it to us. So for instance, you are a writer and you wrote an article that you think could fit inside the Logos Press engine. So then you can just use this form and share your ID with us. And maybe you are a developer and again, you built a whole project yourself and you think it could fit Logos. So you can write to us here, and if we think it's good enough, we can maybe share it with the community, help give visibility to your project, maybe bring people in that could help you. Yeah, basically just give you visibility. And the second thing is issues. So issues is basically we just pull the GitHub issues and just show them here. And you can just use that if you don't have any ID, but you still want to help us. So then you just go to this page, pick an issue, and suggest your solution. And so again, we are right now building this application. So right now we just show the issues from our repository, contribute.logos.co. But the ideal, of course, would be that we have issues from all the projects. So if you think this is interesting to you, and if you have a few issues in mind, well, you could go to our repo, create issues, so they will be shown there. Or maybe you can just reach out to us, Gino or I, and we can find a solution to just fetch the issues from your repo directly. Maybe issues that have a specific tag, yeah, or whatever. So yeah, and finally, how do we think we can activate this portal? How can we motivate contributors to actually work with us? So there, the two features I'm going to talk about are not implemented yet, but we are right now actively working to, well, put them to life, bring them to life, sorry. And so this is introducing a scoring system to build leaderboard, and on top of the scoring system, creating a ranking system that we call the Logos ladder for now. So this core system is quite straightforward. We think it's good if it's based on issues you've created and we've accepted as good issues. Also, pull requests. You might have merged pull requests, sorry, or maybe articles you've written for the Logos Press Engine or anything else. And then we can attribute scores based on this. So we think that there is a part that can be automatically, automatically scored, just basically all the GitHub data. And then we are also working on a way to manually attribute scores to people when they, for example, write an article for us or anything else. And with this scoring system, we want to build leaderboards. So we thought about a seasonal leaderboard that would reset each quarter. And so that means that if you are a newcomer and maybe in the last month you contributed a lot to the ecosystem, you can still be on the leaderboard even though if you've been there just for 1 month. So we thought that it was interesting to have this seasonal leaderboard to directly show new contributors who've been motivated to help us and show them publicly on this front end. But then we also don't want to forget people who helped us a lot in the past and for any reason had to step away from Logos temporarily or maybe permanently. But we still want to showcase them on this historical leaderboard where they can, if they work a lot with us, they will be there and maybe in the top ranks, no matter what the season they participated in. And so, as I said earlier, then we've got on top of this scoring system a very basic ranking system that you can see in other open source organization like Apache Foundation. And this is basically just to give kind of roles to contributors that are more involved in the community, and it can go up to governance level roles where people could maybe discuss together on what projects we could build or what project we should focus on, basically just run the open source community. And some maybe mid-level ranked contributor could be responsible for mentoring the newcomers and so on. And then the 3 points we thought about are just pretty obvious and straightforward: giving shoutouts to people, creating badges like Discord roles. We've already experimented a bit with our contributors on Discord, giving shoutouts also in newsletters. So yeah, all that good stuff. So now it's done for the explanations. I'm gonna quickly show to you how it looks like. So when you go on contribute.logos.co, you've got this landing page, which is the contributor directory. So you can see all the contributors. It's paginated, and if you click on a contributor, you can directly go to his GitHub profile. And if you click on View Details, you just got an in-depth view of everything he contributed to for the last 12 months. And this contributor, for example, he helped us on this exact website. And then, as I showed you earlier, we've got the resources page where we've got guides for each persona we identified. So developers, writers, event organizers, translators, designers. And of course, this is what we thought about. But if you think there is maybe a persona that is really missing there, please reach out to us and let's change that and build that together. So there it's pretty straightforward, just a few words on how you can help us, what you can do to contribute. And then you've got this form, this proposal form. So very basic, you enter your name, you enter a way we can contact you back. So either your email or status app chat key. And then you also select the persona you fit the most in. And we've added this other persona just in case you this is really different from what the other options. And then finally, the issues, as I told you. So we just created 2 issues while developing just to test this feature. And when you click on it, you just go to the GitHub issue. This issue has already been addressed by some open source developer that is helping us. So for translation. So I think that's it. Thank you for listening, and I think that if you have questions, it's now.
We'll probably save questions for the end because there's so much content, but I really like the idea of highlighting and spotlighting all the external contributors that we have. And I look forward to the time when it gets too big and we have to revamp it because we need to figure out different ways to filter all the contribution happening, right? It's kind of like that's what you want to happen. So great job, guys. I'm looking forward to seeing all this kind of roll out into the new websites and people using it and it growing.
Yeah, thank you. Let's activate it more.
Yeah. All right, then I'll drop you guys off and we'll bring on a few more. So thanks again, guys.
Thank you.
Let's see. I'll add this real quick to the stage. Let's see. I wanted to talk a little bit about some of the releases that happened before we talk more. So first off, Farewell to Westphalia is out. You can go buy it. Anyone can go buy it. Let's start pumping it. Leave some reviews on Goodreads, on Amazon, so on and so forth. The link for Goodreads reviews and the book is in the description of this video, as well as in the Notion for any core contributors who are watching. Go find that. Go click on it. Go give a good review. Go buy the book. Tell your friends about it. Give your book to friends. It's what we're about. The next one I'm really excited about to start playing with. The Nimbus team has finally is a strong word here, gotten to the point and come full circle of releasing something they've been wanting to do that's hasn't been done anywhere else, and that is a unified Ethereum node. So if you'd like to run a validator or a node, historically, you have to run 2 different ones, an execution client and a beacon chain client, and those things talk to each other and have various setups, and you can use different clients from different people, and they're all compatible. That's great, but it's kind of annoying. Making sure your JSON Web Token is set up correctly and they're communicated properly, and you have all these things. And depending on which clients you use, you don't know if they're actually connected and how good they're connected or which one's out of sync. You don't have to do any of that crap anymore. Just download and use the unified Nimbus node. Perform it. It's lightweight. Because they're connected, it allows it to take care of a bunch of optimizations to make it even better than what could be if you run 2 different nodes. It's awesome. So go check that out. Go give it a shot if you want to run nodes. I'm going to be playing around with it, migrating my validators to it. And essentially writing a guide on how to do so from both. I run both Nimbus nodes. I'll migrate to this one, which is a little more simple. But yeah, guys, check that one out. Then you have F Status. Status has released their portfolio wallet beta as a browser extension. Go check that out, play with it, break it, see what it can do, see what it can't do, tell your friends about it. Go look at your portfolio through it because it's really pretty. And I think most portfolio apps kind of suck. So I'm looking forward to like putting things in this, seeing how it works, making it look nice, giving feedback, so on and so forth. Also, version 0.2 of the alpha Nimbus execution client was released. Alongside of this, as a consequence, is also the verifying proxy that they have. So go check those out. Update if you're already running these things. As far as presentations go, that's all we have for releases that I could see. So if you're watching this, you're a developer or part of a project, and you do release something, tell me about it because I have to go scour through things, make sure that I'm finding this stuff. So if you don't see it here and it happened, it's because you didn't broadcast it well enough and I couldn't find it. So tell me about it otherwise. Next is coming up. We're going to have Roxana and Aaron come on to talk about some of the circles things that are happening, both from LA and Barcelona, respectively. So we got Roxana and Aaron. What's up, guys?
Hello. Good morning.
Hey now.
How do you want to do this? Who would go first? Let's go with Roxana first. Barcelona.
Okay. Really, really good event. Really great turnout. We had about 40 people in and out. Really good responses. A lot of topics covered, including the ability to think critically, the ability to verify information, kind of a topics like parenting in the form of how do you deal with parenting with all these chat controls and this kind of surveillance state that we're building in each of our states. It was kind of funny. Yeah, propaganda. Kind of people were really disappointed in the technology, to be fair, because we had people from Web3, and they said, well, when we all started, there was this promise that the technology would fix everything, and it kind of it's not where it should have been. So I think there's a huge desire for people to build something with the help of technology, which for me was a great signal for Logos, to be fair, because I feel like people really want to change and improve aspects of their local communities. A lot of focus on education, a lot of focus on different initiatives. Our friends from Akasha Hub are also there. So it's been a really, really good turnout. Marina will lead the chapter there for now until we identify someone locally. And the next one will be on the 8th of October, at the same time as a lot of other events, including, let's see, Brno, Barcelona, Lisbon, and San Jose. Really, really good turnout. I'll drop in the comments a calendar of Logos Circle
Nice.
events. It's a huge request. Oh, has failed. If you can help me bring this to light, a huge request for everyone watching this. Please subscribe because you get notifications if a circle is happening around you. Or if you're interested in doing a circle yourself, you can see what's happening around the world and you can get inspired. That's for circles. Then I want to do a shout out for the interns. We have
They've been busy.
we've been busy. We have Luis, who's our intern in San Jose in Costa Rica. So he will do the first Logo Circle there. He's already secured the venue. It's already in the calendar. He's very excited. We have Lanyan, who is in Nigeria. He's preparing his first circle in Ilorin, his town. Already about 20 people interested. And then we have Khadija, also known as Blockchain Baddie. She's a great YouTuber. She's gonna tune in virtually to talk about Farewell to Westphalia to an audience of academia in Paris in the next couple of weeks. So she's very excited about that.
Awesome. Y'all are really growing. Love to see the rate in which these things are growing. You had one
100%.
more too, didn't you?
Yes, I did. Dark Prague. We're going to Dark Prague. I'm going to do a shout out to people. If I miss anyone, please shame me on Discord publicly. Vaslav will be there. Marina will be there. Martin will be there. Sasha will be there from Waku. And we will have Shirley from Nomos as well. And I will be there. And we will do a very particular circle right before Jared's talk on the 3rd. So the idea is to introduce people into the concept of logos and the logo circles and find someone who can run it locally. So I think we'll have a very good audience, very obviously privacy focused cypherpunk, which should be a really good one.
Should come on the next town hall and talk about how that went.
Yeah, I will.
It'd be interesting. I love Prague. Awesome. Wish I could be there. Aaron, what
Always
about
with
you?
us.
What do you got? What do you got for LA? How did that go? Little puppy eyes.
LA has been great. Hi, everyone. Thank you. LA has been great. The planning for the second event has taken a little bit longer than I like, but we're moving on that as well. I'm trying to lock in an appropriate venue. The first event had about 25 people, a very high. I was very happy with the type of people that came and what their interests are, and there were questions about how to bootstrap these sessions and ensure there's attendance. By the way, I saw the picture from the Barcelona circle. They beat the first Los Angeles circle in terms of attendance for sure. Very impressive. Also, the setting for the Barcelona circle looked very interesting as well.
It is Barcelona.
Yeah, sometimes you can't compete with an old city. One thing I wanted to highlight specifically today, because it is Farewell to Westphalia release week, and shout out to Arseni for a huge influence on this. We have promotional copies of Farewell to Westphalia. Certainly, we have extra copies that we've all ordered to pass out. Something I found that so far has been quite powerful. It's an interaction ritual chain where you give the book to first you ask someone, do you read? And they might say no. I feel like over 50% of people might say, no, I do not. And so you move on. But when someone answers, yes, I love reading, hand them the book, ask them to finish it at their own pace, at their own leisure. When they finish, to leave an anonymous note somewhere in the book, return it to you, where you will then pass it to the next person who has not yet read Farewell to Westphalia and enjoys to read. Then they will find the anonymous notes, continue in the interaction ritual chain, return it to you, and so on and so forth. And hopefully they become inspired to do the same if the book impacts them the way that it has so far. So for some people, I think this is quite powerful. It's at least a very lasting impression. People will not forget you or the book or what it stands for, or what it communicates, and hopefully we'll be inspired to continue that change. So I'm very curious to hear how other people might experience this, or their experience in initiating this ritual chain. And look out for imminently for the second Los Angeles Circle announcement in Luma, and it will be in the calendar, the aforementioned calendar. I think that's about it for the moment.
That's awesome. I'm going to adapt your strategy. I think it's better than my throw a book at everyone I see strategy. That feels way more intentional than what I'm trying. All right. Well, we have a lot of content. As much as I'd love to continue ruminating on future of circles, I'm gonna have to let you go. Thanks, guys, for coming on. And gals. Up next, we didn't say who was gonna go next, so I'm just gonna pick at random. Why don't we have Yuri come on and talk about some sweet, sweet Logos core action? Yuri.
Hi. So today I'll not talk about Logos core itself or the Logos app. I'll talk about the SDKs because it's an aspect that we haven't really talked about much before. And I'll start with the GS SDK, and this is to give some idea where we're going with this. And this is a bit a mixture of ideation of where we want to go and what's actually there. So if you think about the dependencies file, and we have actually something like this already, we just call it metadata .json at the moment. And the dependencies, instead of being an object with versions, is just a list. Because at the moment, we're still working on this, so it's all working locally. But you can picture that you have dependencies and you specify certain versions, can either be local, can be on a peer-to-peer network. And then you do something like logos install. So if you have worked with things like CocoaPods, Bundler, and so on, this should be very familiar to you. And in the case of the GS API, we have a npm package. So this is not published yet. It might have a different name. But the basic idea that you have a JavaScript app and you just do require the package and you start a new Logos core. And that will then spawn the Logos core instance and load any modules that it needs to load, instantiate them, and take care of all of that. But from the developer perspective, for the dev experience, this is all that they need to do. They don't need to worry about all those details. And in terms of API pattern, we are aiming for this type of pattern that it's very predictable, which essentially do logos dot the module that you want to interact with and the method. So doing calls, and this is the API right now, which is right now in the develop branch. If I want to say I have the chat module, I can say, logos.chat.join channel, and I join Bashish Yadu, or I want to send a message, it's the same thing. And to react to events, is we have something like that. We do on chat message, and then we do what we need to do. And we want to do the same type of patterns with different SDKs. So whenever you might be using JavaScript or C++ or NIM, you have the same, more or less the same way to do things. So it becomes more predictable. And this is so we're doing some comparisons of all this looks like. So this is actually the API right now on the develop branch. The C++, it has a different API. It's in a different branch. We're currently working on this. And you can see they are very similar. It's essentially the same idea. You require the logos package, you start an instance, and that's all that you need to do. And you can see the similarities between those. And then API wise, it's also a similar pattern. So it's always logos dot the module dot the call that you want to do. And you can see that looks slightly different because it's still a work in progress. We achieved this through different methods. So in JavaScript, we actually do it at runtime. In NIM, we're doing this using macros. So it's still a work in progress. I'm hoping to remove the need for that call and just have the join channel. And in C++, we're doing this through code generation. So it's a nice API, easy to use. And for events, similar. They also look somewhat similar, and how you can you can achieve this. So again, this is right now the develop branch. The C++ one looks slightly different right now, but on a different branch. This is how it looks. And now I'm going to do some live demo. Let's hope this goes well. I don't know if you saw the Facebook one, the Meta one, that didn't go so well. So let's fingers crossed. I already compiled the stuff, so I don't need to worry about that, and we don't need to wait so long. So I'll first start the logos app, and I already installed the packages, and I'll just start first the Waku module, the chat module, and then I'll open the chat app. So you see chat a lot because that's kind of like the main module that we have right now, and the teams are working on creating more modules, first as C libraries, and once it's done, we can actually put these as logo module and start to build more apps. So okay, first we have this app, and now I'm gonna load another module that was developed, which is the IRC, and this module connects to the chat module and essentially creates a IRC server and proxies to Waku. So then I'm gonna go here to WeChat, and WeChat I already have it configured to connect to my instance. So you can see it load the chat history. You can see here there's the logos symbol, which comes from that module, and I can say hello from IRC. And if I go to the app, you can see hello from IRC, hello from C++, hello from C++. Then we also have an Electron app, and you can find this. You can find this at examples, Electron app, and I'll just do npm start, and this loads. So this starts its own logos instance. It starts its own Waku instance, and I hope this does not affect my connection because at this point it's pretty much 2 or 3 Waku instances. So let's see. Should fetch the history. Fingers crossed. Yes, it did. It did. So I see hello from. I'm gonna put here the WeChat. So hello from Electron Node.js. And come on. Yes, it did work. And you can see it also hello from ERC again. And hello. Well, it should work. This didn't work. Okay. Yeah, it did arrive. Yes, it did arrive, one of them. Okay, and I can even run another one. So I already there's a name one. I already pre-compiled it, and this has no UI, so you just see the logs. But yeah, just have to take my word for it. It does work. We do have some kinks to work out with the events, but it's also doing the same thing with the API that you saw. And okay, since this kind of went okay, or at least it went better than the Meta Glasses one, there's another bonus that the Status team is working on the wallet SDK. Specifically, Dario has been leading this. And there's an experiment to try to create that as the C library and then as a logos module. So the API pretty much works as you expect, the same pattern. So it's logos.wallet and, for instance, get add balance just for testing. And I did here a very quick Electron app. And okay, I need to do some initialization. And I'll put here address. I'll put the null address because that's good for tests. I say get chain ID, and that works. Get add balance, and should be this huge number. Yeah, and that's the actual balance. So it's all work. So as we get more modules, it will become easier to share the stuff that we do with the world. It'll be easier for developers to build on top of what we do, and we should start to open up the possibilities of what we can do with this. And I vision in the first stage, we'll do probably some internal hackathons or something to work out the kinks, find out the pain points, and then we'll be ready for the wider world.
Awesome.
That's it.
Yeah, it's really awesome, man. You're just going all over the place. You're hitting all languages, all platforms, all modules. I look
Yep.
forward to having the wallet in there and having some account management type stuff, so you can basically manage your identity within whatever applications you're building easily, right? Like having that identity module allows for better persistence and kind of account management across whatever app you end up building. Easier.
Yeah, absolutely. I mean, there's a lot of possibilities. I showed here a case that they kind of spun their own, for example, Waku instances, but it's possible they can also reuse depending on how we configure. And we can imagine scenarios that perhaps you have a module like the identity module, and you have different apps all connecting to it. And from the dev perspective, it's all a very seamless experience, and how to do that.
And expanding that even further, I know some of the plans for Logos Core is to run multiple remote sessions of Logos Core that connect to each other. So you basically could have like a Logos Core instance running on a server that manages your Waku instance. You can have maybe a hardware wallet that runs Logos Core that is kind of where you're signing things, that is your account management system. So you have the right software working on the right hardware, but managed in a single instance, that your applications are all using the same thing. And your infrastructure, like topology, looks and operates appropriately, as opposed to like what you just currently did, which is like, I'm running multiple instances of the same thing on the same computer. And it's a great, it's great for demo purposes when you think about how these networks are actually run or should be run in scale. Having that feature within Logos allows you to do that while still having a good experience. Like I'm so looking forward to something like that.
Yeah, super excited about this. There's so many possibilities on what we can do.
And what everyone else can do, not just us.
Yeah, exactly. We want the stuff that we do to be used by others. We want to make it available, and we want to make it as easy as possible to build on top of it. We have to make it that simple.
For sure. Thanks, Yuri. I really appreciate that. Awesome stuff. I love seeing the developments.
Thanks for
go on the Logos Core channel of the Discord, ask questions, add things, build stuff. Thanks, Yuri.
Right.
All right, up next, we can go over in time. If you get bored of watching us, or you got to go, this is all recorded. You can just watch it later. So I'm gonna bring on David and Alexander to talk about some sweet stuff. I read the blog they all recently put out about this concept within Nomos, and Nomos operates differently than a lot of L1s. And so when you write these blogs that start to explain some of the differences and the solutions you've had to come up with for solving the problems that need to be solved, such that you have good user experience and you have fair games and stuff like this, I love it. But like, the more we do this, the more people start to understand like how Nomos is different, and the brilliance y'all have done in coming up with different ways to make it work and be different. So yeah, thanks for coming on and starting to talk about some of the work you're doing.
Cool. Thanks, Corey. So this is Alexander and I are going to talk about the lottery difficulty problem in Cryptarchia. This is some work that Daniel, Cash, Alexander, and I have been working on for some time, and we just wrapped it up. And we're going to present some of the analysis that we did and some of the results, and some future work that we might work on in the future. Here. So Cryptarchia is the consensus protocol that we use in Nomos. It's a Bitcoin-inspired protocol. So it does Nakamoto consensus, but it does it over proof of stake instead of proof of work. So participation is permissionless and private. We don't know how much stake is active at any point in time. And so nodes can join and leave as they wish, and that can change the rate of production of blocks in the network. So we have to adjust the lottery difficulty to maintain a target block rate, just like how Bitcoin does it in proof of work. The lottery difficulty in Cryptarchia is controlled by an estimate of true total active stake, and so a lot of this discussion is going to be about how we actually infer this active stake from the activity of the network. So some prior work here. So of course, Bitcoin, they dynamically adjust mining difficulty to maintain a stable block rate. We'll talk about how exactly they do this. DarkFi made an attempt at this. They tried to do this with a PID controller when they tried to implement this a similar system. But there's some issues with their approach. We're not going to go too much into that, but it just, the approach didn't work in our opinion. Praus, which is what Cryptarchia built on top of, has public participation. So we can actually measure the total active stake. It's very easy to then, if you know the total active stake, you can adjust the lottery difficulty directly using this value. So they don't have this issue. So Cardano does not have this issue. They use Ouroboros Praus. So that's some background. So Bitcoin is the closest analogy to what we're doing. Mining is permissionless and private, right? Nobody knows if you turn on a Bitcoin node. You can just mine privately and then submit a block privately, and nobody will be able to track it back to you. We want to simulate that kind of a network in Cryptarchia, where you can privately produce blocks and in the same way as Bitcoin. So the true hash power of the network is unknown, and they need to maintain a target block time of 10 minutes, even in the face of nodes coming and leaving. So the way they do it is they adjust the mining difficulty every 2015 blocks to target 2015 blocks produced in 2 weeks. And so this is the actual equation that they use here. They take the actual time it took to generate 2015 blocks and then divide it by 2 weeks is the target time. And then that gives you a ratio of what the actual production rate of the network versus the target. And then you just multiply your difficulty by that ratio. And that gives you your new difficulty target. So in Bitcoin, when you mine, you have to produce a block ID that is below this difficulty number. So Cryptarchia is very similar, but the fact that it's proof of stake, it's a bit more complicated because we need to deal with a lot of the problems that come with proof of stake. For example, we want to make sure that people cannot grind their secret keys so that they can have an advantage in the lottery, right? So we have to do some changes to how this lottery works. And so time in Cryptarchia is divided up into these slots that are 1 second long. And then we group these slots into epochs. At each slot, any node who has held NMO for at least 1 epoch is eligible to win that slot and produce a block. And then the amount of NMO that you hold determines the probability of you winning that slot, right? So if you hold more NMO, you're more likely to win the slot. And then nodes will produce a ZK proof that they've won the slot, attach it to a block proposal, and then send it through this through the blend network, which is like an anonymization layer of the network, so that you can track who proposed a block. And then because everyone's doing this privately, there's no coordination about who is proposing at each slot. You can have potentially many different proposers at every slot. And so we resolve forks by using longest chain, just like Bitcoin. So this cryptarchy tries to be very like in spirit, be a very close analogy to Bitcoin. It tries to do as much as we can, just like Bitcoin. And so you'll see those analogies there. Right. So how does the lottery actually work? So each eligible participant compares a ticket that is derived from a VRF, like a hash function, to some threshold. And this threshold is dependent on their private relative stake. So this box here, this is the threshold that we use in Cryptarchia. And so it's just like mining, right? So in Bitcoin, you try to mine a block header that is below the difficulty threshold. In our case, this is our threshold for Cryptarchia. So if you happen to generate a VRF value that is below this threshold, you win the slot and you can propose a block. And then the lottery is designed so that about 1 in 30 slots are occupied. Of course, this is a random number, right? So it's gonna vary, but roughly every 30 seconds, since the slot is 1 second, every 30 seconds we should see a block. Yeah. So that's the high-level overview of the lottery. I'll hand off the exact details of the inference process to Alexander to go through.
Okay, so now, as David explained, that we need to somehow estimate what is this total active stake, and for this we kind of use some sort of like an inference algorithm, and then one can look at it as a statistical inference. So what this algorithm does, basically takes some parameters, like which are, for example, which are fixed, which is f, which is a target slot occupancy rate, which is known and fixed. Also, the capital T, it's the number of the slots in the epoch. And also we have a h, which is a learning rate, and learning rate, like we control this learning rate, so we can set to some sort of a value. And then what happens actually that it uses the number of blocks in a honest chain, right, to update the stake. So it takes the estimate of a total active stake in a previous epoch and uses this equation to compute what's coming next. And then, of course, because the number of blocks in a honest chain is a random number, so this estimate of a total active stake, it's also a random number. Over to you, David. Next.
Okay. So we've done some simulations on that process just to see the behavior, and here you can see two plots. One showing a 50% shock in stake, both increase and decrease. So 50% shock increase is when you get a large increase in participation, and conversely, when you lose half the stake participating in consensus. And you can see we can converge very rapidly. Within like 2 epochs, we will converge to the new stake estimate. Yeah. So with this process, we had to this looks simple-ish, but we wanted to understand the implications of this process. Because it is a random process, and so we needed to analyze some of the properties of this process.
And so the simplest properties which we can analyze and which kind of useful, it's actually what is this number it converges to, and what is the average of this number. And in this case, what you see, I mean, it's the ratio between the average of this converged value of the inferred total active stake divided by the true active stake. And this is somehow, it's a measure of accuracy. And what we see here, that we have a result, and this result, as you can see the right-hand side, depends only on the f, which is, as I said, it's kind of a fixed in a protocol. And it also depends on q. And q, it's it's the honest slot utilization rate, and David will talk about it in the next slide. But from this slide, what we see that if Q is less than 1, it's a number between, let's say, it's a positive number which is less than 1. If it's strictly less than 1, then what's going to happen, that this accuracy is going to be less than 1. So that means that we always underestimating stake if Q less than 1. But if Q is equals to 1, in that case, the accuracy value is 1. And what it means that this average of this converged or equilibrium inferred total active stake is equal to the true stake in the system. Over to you, Dave.
Right. So so this Q parameter here, the honest slot utilization rate. So when we first analyzed this process, we considered the case above in the first plot here, where we could measure every slot that's active, even across forks, right? So here you can see blocks produced forking off of the honest chain. Different blocks are using different slots, right? We can only actually measure the slots that are on the honest chain. So we're missing a good portion of the slots, right? To get a very accurate measurement of total active stake, you should be measuring all of the active slots, not just the active slots on the honest chain. And so this Q parameter is something you can measure from simulation. It's not something that you can just set as a protocol parameter, right? This is just something like a property of the system. If it's too low, then we'll have a very low accuracy estimate of total stake. So we did some simulations to see what would be the implications of this Q parameter. And what makes things more difficult for Cryptarchia is that it runs on top of the blend network, which adds some broadcasting delay to the blocks, because we want to break the connection between the proposer and the receiver, because we want to maintain some privacy for block proposers. So on the right here, you can see the implications of, on the left, you can see the implications of increasing the mixed-net blending delay. You get an increased amount of reorgs or forking in the network. The higher the lines here, the higher the frequency of reorgs. And so you can see as the blend net delays increase, reorgs increase. And similarly, for the total stake inference process, we can see that as you increase the network delay, the Q value decreases, and we get a less accurate estimate of total active stake. When we took the parameters from the blend network and plugged it into our simulations, we got a value of around Q equals 0.85, which puts us around here. So we'll have, like, the expectation is that we'll have an underestimate of total active stake by around 15%, because of our network conditions. Okay, Alexander, I'll give it back to you.
Okay. So on previous slides, we talked about accuracy and how this accuracy depends on this Q parameter, which is itself, as you've seen, basically depends on things like network delays. Now, what we can also say something, we can say about actually the precision. And precision, it's related to the variance. It's related to the variance of actually, again, of this converged value of the total active stake, which we inferred. And that, as you can see here, this variance is bounded by some simple expression. And in this expression, we see that we have f, which is fixed in the protocol. We divide this also by t, which is the number of the time slots in the epoch, and this number it's roughly, I would say, around, let's say, 500,000. Yeah. And also we have a h square, and h is a learning rate. Again, we fix this learning rate. So it's again, it's going to be fixed in the protocol. And one can actually see here that if you choose h, like kind of reasonable, yeah, then this variance is going to be quite small, which is a kind of like a good news for this protocol. That means we're going to have a quite low variance of the estimator. Over to you, David.
Right, and we see this in simulation as well. So we modeled the predictions from analysis, and then actually measured the actual variance of the inference process, and we see that variance is, as you can see, very, very low. Mostly coming from the fact that our epochs are so long, roughly 1 week. And so that gives us enough time to accumulate a lot of data to get a very good, precise, accurate, measurement of total active stake.
So we talked about properties of the estimator of the total active stake, but also, I mean, we have an algorithm, right? And this first equation, which you see on the first slide, is kind of an algorithm, but also for this algorithm we have a stability condition, and its stability condition, it's how basically suggests us how to choose the learning rate. Yeah, and here. What we can say that if this h learning rate is chosen according to this expression, if it's below, the right hand side, and then this algorithm is going to be stable. Over to you, David.
Right, and again, in simulations we see this. So this red line here is that upper bound on the right here. If we choose h larger than this upper bound, we start to see that the inference process diverges, and we get crazy values for the total active stake.
So this algorithm, we can show that it's stable, also that it has a low variance of estimator, and there is some more good news here that actually we can show that this algorithm converges exponentially fast to this expected value, to this equilibrium expected value of the inferred stake. And this comes from this expression you see on the left-hand side. You have if you like, a distance between the expected value at infinity, so that's kind of like equilibrium value, and also at any epoch. And this sign simply here, like in the middle, means that it's proportional to something, but this something, it's, let's say, it's a positive number which is less than 1, and it's in the power of the epoch. So clearly, I mean, this number on the right-hand side, it's getting small very fast with the epochs, and that means we have this algorithm converges very quickly to its kind of like equilibrium value. Furthermore, we can actually use this expression above and some other analysis which is not shown here to choose an optimal learning rate. And it's shown here on the bottom of this slide, this value of the optimal learning rate. And if we run this algorithm, so as I mentioned, that this convergence in generally it's going to be exponentially fast. But if you run this algorithm at the optimal learning rate, then convergence is going to be double exponential. So it's exponential like exponential. So it's like super fast. Yeah, so this is like more good news about this algorithm. Over to you, David.
Right, and this is simulations here. You can see this is the normalized error plotted across epochs, And when you use the optimal convergence rate, you see that we get to like 1/100th of the true active stake after 2 epochs, which is very very fast. So conclusions, simulations show that with our network conditions, we should expect something like a 15% underestimation of total active stake. But despite that, we have we achieve stable block production rates, even when participation changes rapidly and quickly. And we have a protocol that still maintains the security properties of Ouroboros that we build on top of, and is efficient to actually compute this. We have some ideas on how to remove this bias introduced by the Q parameter if we use uncle references to point to blocks that are off of the honest chain. This way we can actually count all of the active slots, not just the one on the honest chain. Yeah, that's our work.
That's awesome. I read this blog post and I really enjoyed it because it's an analogy that I'm playing in my head around this work, and what I think is missing for people to understand how interesting it is. Because if you look, like I do a lot of long range precision shooting. I'm an American, of course, so and that's where I shoot targets from really long distances away. And when I'm thinking about making that analogy, what Bitcoin does, if we look at Bitcoin and how you're trying to mimic it, when you're shooting at a target from a long distance, you're looking through a scope and you adjust it accordingly, and then you fire. And depending upon wind speed and distance and bullet drop and all these interesting things that happen, it doesn't necessarily, you're aiming at the center of the bullseye, you may hit a little bit different, right? That's your accuracy. And then you can see it. So I'm aiming at the bullseye, I hit a little bit different, my accuracy is a bit off. And if I do this consistently, I shoot a bunch of targets, I shoot a bunch of bullets at the bullseye, the grouping of my bullet is precision. So I can be really precise. I hit the exact same spot that's different from the bullseye. I'm really precise, but I'm inaccurate. But because I have this nice scope, I can adjust it accordingly. What Bitcoin does is it adjusts its scope so that when I'm aiming at the bullseye, I hit the bullseye. And then I have precise, if I have good, all the other things, then I can be precise. So I can hit the bullseye precisely. I can see all of these things. And in Bitcoin, you can. But with Cryptarchia, you can't because it's private. What you've done, this work, and the way I'm picturing it in my head, is that you remove the scope because you want privacy. And you've come up with a way to still get both reasonably well. You can still be accurate and precise up to a sufficient degree where you can do long-range shooting without a scope. And I think that's really interesting, right?
Right.
And you come up with new ways. The uncle rate was something I was going to ask about, because that's what Ethereum did when they reduced the block time significantly and still wanted to try and maintain some level of consistency and convergence by introducing uncles and being accurate.
Yeah, right. So, yeah, Bitcoin gets away with a lot because of their 10-minute block times, right? Mm-hmm. Like you can have, Bitcoin on the moon or something. With our 30-second block times, and layered on top of that our blend network, it really compresses a lot of the propagation time into like a very small window. And so yeah, I think uncle references would help a lot in improving our accuracy. Our precision is already very, very good, but our accuracy could be helped with that uncle references. Yeah.
That's really interesting. Another thing I was interested about is like, why do all this work? One, you're getting rid of all the miners. That's nice, right? You get rid of all the computational work, the energy requirements of running the network. We're doing this through proof of stake while maintaining some of the properties of Bitcoin, which are really nice for permissionlessness and privacy. I'm curious. In the beginning of Bitcoin, the idea was one CPU, one vote. But through the course of ASICs and optimizations and centralization initiatives, you end up with this pool behavior where people contribute to pools such that they smooth out their ability to gain rewards. And because the probability of winning the lottery and getting a full block is really low. So if you contribute to a pool, you get percentages of whatever that pool gets, commensurate to your contribution to that pool. But now that's changed the dynamics drastically from the original vision of Bitcoin of one CPU, one vote. Do you see that happening with something like Cryptarchia, or is the way it's constructed kind of keep this one CPU, one vote analogy strong?
Well, I think what might help there is the fact that participation is very, very cheap, right? You don't have to run a miner burning electricity, right? You just have to run this very inexpensive check of like, did you win this slot, right? So maybe that will help people avoid centralizing into pools. But we have seen this kind of pooling. We borrow a lot of work from Cardano here, and Cardano did move into this whole very centralized pool design, right? So there's a risk there. Yeah, it could go either way.
Hard to say, yeah. Maybe for a longer discussion, because I have so many questions. I find this fascinating, but really awesome job, guys.
One last thing. So this is something that came up while preparing this presentation. I wanted to try to see if we can make this this equation look a little bit closer to Bitcoin's equation, which is much simpler, right?
Yeah.
Just to make it easier to understand how ours relates to Bitcoin. So it turns out that there's a very simple derivation you can do here. That if you use the optimal convergence rate in our protocol, you get this. Our inference process converges to or simplifies down to this equation here, which looks almost identical to Bitcoin's difficulty adjustment equation.
And there's no approximating assumptions here either, right? This is just a different derivation.
There's no approximations here. This is just use the optimal learning rate, and then you get this. The difference is that in Bitcoin, you produce 2015 blocks in a certain amount of time, whereas in our case, we wait a fixed amount of time and then measure how many blocks we produced in that time, right? Mm-hmm. So in Bitcoin, you measure time from a
that has to do with like that's a fundamental difference between proof of stake and proof of work, because with proof of work, you're putting stake up front that's external, and proof of stake you're putting up a stake up front that's internal to the system. And so like how you can participate is differentiated based on that fact alone, which would change that behavior.
Yeah, but the equation is like identical to Bitcoin.
Same thing, same behavior. It's really cool.
In the end, we're just rediscovering Bitcoin. You know, that was a
but more efficiently. That's the key point. Yes. More efficient.
Yeah, I think with this protocol, I think Cryptarchia is like the most like spiritually it's most the closest implementation of Bitcoin in proof of stake. There's nothing else that does this closely.
Yeah, I think it's worth continuing to push that narrative, because it's a powerful one. I mean, Bitcoin's around for a reason still.
Mm-hmm.
All right, guys. Yeah. I look forward to continuing this and seeing more of the work y'all are doing for coming on. And thank you all for joining and listening. And if you have questions, go to Nomos Discord, ask me questions. I'll point you in that direction. Talk about it. Tell your friends. Ask questions. Break it. Contribute to it. See you in 2 weeks.
Cool. See y'all.